Hello everyone, in this video I will discuss about the scenario which is based on quality control in manufacturing. This scenario is collected by my colleague Jian Huang, who is a lecturer in hospitality management. So there is a company called ADP, which is a mid-sized company and which manufactures widgets, and there are 3 production lines which produces 1,000 widgets or batches daily. Now, what we need to check is whether the widgets quality are controlled or not, whether the process is under control or not. So the business problem for this one is to analyze the defect rates and identify whether there any patterns or anomalies are there or not. Now to do that, we will use a statistical process control. And before that, these are the data collected for 820 batches, which are producing 1,000 widgets. And each batch is producing these are the numbers of the defective widgets. Statistical process control is used to understand that whether the process is under control or not. Now, there are different methods out of that. The control chart is the most popular statistical process control. There are 3 key elements of the control chart: mean, lower control limit, and upper control limit. These control limits are like traffic lanes, which help to determine whether the process is stable or under control or not. And we can calculate this lower control limit and upper control limit by mean plus minus 3 times standard deviation. And we can decide the process is stable if 68% of the data lies between mean plus minus standard deviation, 95% of the data lies between mean plus minus 2 times of standard deviation, and 99.3% of the data lies between the lower control limit and upper control limit. Now we'll see in Excel how to plot the control chart and how to do the analysis based on control chart. So we have the data here, batch ID widget produced and the defective widgets. So I just copied the batch ID and defective widgets here. Now I will calculate the mean here. So the formula for the mean is equal to average. And then you will select the data completely for 20 widgets. And because we want it to be static, the same data for the whole column, so I will include the $ before. So I can write $ for the row as well as column number so that the data becomes static for me, and close the bracket and press enter. So you will get the mean here, and then we will double click this one so it will fill the same value because we have made that data static. Now standard deviation we can create using the formula is equal to stdev dot s because we want for sample, and we will do the same thing. So bracket, select the data and made it static. So select the data, close the bracket, make it static. So I made the data static and I can click the double click. So I got the cell here. So I can take tilde decimal place, and then for lower control limit is equal to mean minus 3 times standard deviation. So I got the lower control limit and is equal to mean plus 3 times standard deviation is my upper control limit. So It will be same for all the cells here. So we can also calculate mean plus minus standard deviation. So is equal to mean and then minus standard deviation and is equal to mean plus standard deviation. So this is here where the control limit for the 68% of the data. Now we need to plot the control chart. So for that we will select this data, first two data and the mean, and then we need to select the lower control limit, upper control limit, 1 sigma and control limits, 1 sigma control limits, and then press insert line chart. So if we can get this chart here, and we can see we have a kind of the control chart, but we need to modify this one. So how we can modify? So we need to format. So we don't want the grid lines here. So I can just remove the grid lines and remove the legends and then add the axis titles here. And we can edit the axis title, the horizontal axis as your batch ID. And your vertical axis is defective widgets. And then I can edit my line. So the markers, I can include the marker options built in, and I can include it as circle. I also can include the color as red for that, as well as the fill color as red. And for the same line as well, I can include the line as red. Now I don't want this thickness in this line, so I can reduce the thickness here. So thickness for the other lines which are not that much needed, not to be highlighted, and the lower control limit and upper control limit as well. I can also include this as some different color because it will appear as the same color here. Probably is also there. So I can include yellow line. Right, and then this one I can include as dashes, and here also I can include as dashes just to distinguish between our your other important lines like mean, LCN and UCL. And here the upper control limit, I can include the data label, and then I can edit that data label as your UCL and here also. So this data level I want on the top or on the bottom, so that you can decide. So suppose I want on the bottom below, so it is UCL, and here I can write, include the add data table, write LCL here, format the data table above so that it is clearly visible, and the same thing I can do it for mean as well. And I can again format it. Now this is my perfect control chart for quality. So my control chart is ready. Now we can do the analysis here. So I can conclude that here all the data defective widgets are within the lower control limit and upper control limit. That is, all the data, 100% of the data are within. So therefore the process is stable, as well as we can see the few outliers if we are considering plus minus sigma here, that is plus minus standard deviation. So we can see 1, 2, 3, and here 4, 5, 6 outliers. And 6 outliers means 14 out of 20 are within the range. That is, more than 68% of the data are within the range. So therefore the process is stable, and we can conclude that the company can keep on producing the widgets without having any difficulties. So this is how we create the control chart and check on the process whether it is under control, whether it is stable or not. Thank you, everyone.